All right, hello class. So we are covering 7.4 basic trig equations. We are wrapping up chapter 7 here, and then we will start with chapter 8. Okay, so 7.4 basic trig equations. Okay, so just a note, if you need to verify something as a solution, just plug it in and see if it satisfies the equation. All right, so let's go ahead and start off with our solving. Okay, so let's take a look at this. Suppose that we need to solve 2 sine x plus 1 equals 0. Okay, so we have this equation, and just like equations in general, you want to try to get the variable, or at least the function with the variable, by itself. So we are going to subtract 1 here on both sides. And then I'm going to divide by 2 on both sides. And that gets my sine x by itself. So here, now I need to try to think, okay, well, what angles have a sine of -1/2? Okay, so, well, if you remember, sine is positive here and here, because sine are the y values, and negative here and here, right? And so we know that sine of pi over 6 is 1/2, okay? But we don't want pi over 6, because pi over 6 lands over here in quadrant 1, and the sine of pi over 6 is positive 1/2. We want negative 1/2. So we want the reference, we want the angle that lands here and here that has reference angle pi over 6, okay? So we want the one that has reference angle pi over 6, okay? So we are going to take all of this here, okay, which is 6 pi over 6, 1 pi, plus 1 more. So this is 7 pi over 6, okay? And then remember, to go all the way around, full circle, is 2 pi. Okay, or another way to look at it is 12 pi over 6, which is 2 pi. But we are just short 1/6. So we are at 11 pi over 6. Okay, so here we get that x is equal to 7 pi over 6. Okay, and then any angle that lands there, full circle. Okay, if I add 2 pi, I will land here again, add another 2 pi, land here again, add another 2 pi, land over here. And whatever angle we have there, the sine of that angle will be -1/2. So we have more than one answer. We have infinitely many. So there's no possible way to list all of them individually. So we just say 7 pi over 6 plus any number of 2 pi. Okay. And then we do the same thing for the other one. For 11 pi over 6, we say x is equal to 11 pi over 6 plus any number of 2 pi. Okay, so whether it's positive or negative 2 pi, going positive 2 pi, negative 2 pi, any number of full circles will land you in the same place. Okay. So we have this answer, and we also have this one. Okay, where n is an integer. Okay. Okay, so let's take a look at another one here. solve 3 cotangent squared x minus 1 equals 0. Okay, so again, we have that cotangent x there, so we're going to try to get that cotangent x by itself. So let me write the problem down here. Okay, so add 1 to both sides, right? Divide both sides by 3. Okay, and now take the plus minus square root of 1/3. Okay, take the square root of both sides to get rid of that square. Oops, to get rid of that square like I was saying. And we get plus minus the square root of 1/3, right? But that's the same thing as saying cotangent x equals plus minus 1 over square root 3. Okay. So we're taking both the positives and the negatives here now. So that means we are going to take the angles in all 4 quadrants. Okay. The one there, 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 and there. That have reference angle pi over 6. So we'll take this one, which is pi over 6, okay? And we will take this one over here, which is just short of 6 over 6, so 5 pi over 6. And this one over here is just one beyond 6 over 6, so that's 7 pi over 6. And this one over here is one short of 12 pi over 6. So that is 11 pi over 6. Okay, so we want all of these angles. We could do what we did up above and write the answer one for each of them like this: 7 pi over 6 plus 2 n pi, 11 pi over 6 plus 2 n pi. We can do that for each of them. That's one way, right? We could do pi over 6 plus 2 n pi, 5 pi over 6 plus 2 n pi, 7 pi over 6 plus 2 n pi, 11 pi over 6 plus 2 n pi. Okay, we could do it that way. An even more efficient way of writing the answer, if you notice, from here, from pi over 6, here, let me get a different color. From pi over 6 to here, that's 180 degrees, right? That's pi. So I could write my answer. I can knock out both of those. Anything that lands here, all reference angles that land there, and all reference angles that land here, I could get them all just by saying pi over 6. Oops. Take that off. Pi over 6 plus, instead of saying 2n pi, 2 pi is one full circle, right? Any number of full circles, any number of half circles. So I'll say n pi. And that'll get me all of the ones that land here at pi over 6 and all of the ones that land at 7 pi over 6. Because if I add another half circle, I land at pi over 6. Add another half circle, I land over at 7 pi over 6. Add another half circle, etc. Okay, and the same thing can be done with 5 pi over 6. Okay, we can see 5 pi over 6 and 11 pi over 6 are 180 degrees apart, or pi apart. Okay, so we can do the same thing here. Okay. So we get these two here. Okay. Let's take a look at another example. Solve 2 sine squared x plus 3 sine x plus 1 equals 0. Okay, so unlike the other two previous examples, this one has 2 sine functions with x. Okay, so in this case, you have to try to pay attention to its structure and see if it fits the structure of a quadratic. And it does. Okay. So this is like if I let sign be u, the letter u, then this could easily be written as 2u squared plus 3 times u plus 1, right? And then you can factor. Okay, so but I'm gonna go ahead and just factor directly without replacing the sign x with a u, because I can see it. If you need to replace the sign x with a u so that you can see it, so that it's written like this, and then you factor it, that's fine. You can do that, but then don't forget to still go back and solve for sign. Okay, I'm gonna just keep it as is, no u's. All right, so what times what is 2 sine squared x? Well, that's got to be 2 sine x times 1 sine x. Okay, and I'll have both signs are going to be the same. Both of them are going to be positive. There's only one way to make 1. That's going to be 1 times 1. And then check to make sure you get the middle term. Outside 2 sine x and 1, that's 2 sine x. So outside combined with the inside will give me 3 sine x. So this is fine. So we factored correctly here. Okay, so then we, just like in regular factoring, we take each factor and set it equal to 0. And now it's like we have 2 equations that we need to solve. Okay, so I'm going to start with this left one, subtract 1 on both sides, divide by 2. Okay, so we already did this one. This one was at the very beginning problem, right? So we already know the answer to this. It's going to be all the 7 pi over 6s and all of the 11 pi over 6s. Okay, so we have these answers for this first part. And let's go ahead and solve the second equation, sine x plus 1 equals 0. So let's subtract 1 on both sides. Okay. And sine x equals -1 when x is 3 pi over 2. Okay. Plus any number of full circles. Okay. So this here, these would be our solutions. Okay. All right. Let's take a look. So those are all the solutions. Let's take a look here. So when they say find all the solutions, they're saying do this plus 2n pi business. Okay. All right. As opposed to something like this, if they say solve secant x cosecant x equals 2 cosecant x, solve this equation on this interval, on the interval from 0 to 2 pi, they mean to just give the angles that are solutions to this that fall within that one circle, 0 to 2 pi. Okay, so let's go ahead and take this equation. Now, it's going to be important that you recognize what you're supposed to do when you're given an equation, because this easily looks like a verify this identity kind of a problem. So make sure you read the directions carefully on the test and make sure you know the difference between verifying an equation and solving an equation. Okay. All right. So here I'm going to go ahead and set this equal to 0. So I'm going to subtract 2 cosecant x on both sides. Okay, setting it equal to 0. All right, and then here, let's see, what can we do here? All right, we can factor, common factor. So we see that these two terms have cosecant x in common. So I'm going to factor out cosecant x. Okay, and that will leave me with secant x minus 2. Okay, and now I can take each factor and set them each equal to 0 and solve, just like I did in the previous example. So cosecant x equals 0, or this factor, secant x minus 2 equals 0. Okay, so this one over here, cosecant equals 0, right, or 0 over 1, which means that the sine x equals the reciprocal of that, 1 over 0, right? Well, does that ever happen? No. Okay, so this never happens. Sine x, there's no angle whose sine is 1 over 0, because 1 over 0 is undefined. Okay, so this is undefined. So here, there's no solution from here. Okay, so then that means our solutions must come from the other equation, the other factor. All right, so secant x minus 2 equals 0. So let's go ahead and get the secant x by itself, add 2 to both sides. Okay, and that 2 is the same as 2 over 1, right? And so secant, so that means cosine x equals the reciprocal, which is 1/2. Okay, all right, so we want to know for what angles is cosine equal to 1/2. Okay, and it's positive. So remember, cosine is positive here and here, negative over here and here, right? Because cosine is associated with the x values. Okay, and x values are positive there and there. Okay, all right, so that would be pi over 3. Okay, so that would be pi over 3, which comes from here. Okay, and then the other one would be way down here. Okay, but we don't want to say negative pi over 3. Okay, even though it does land in that same spot, because it gave you this restriction. They want the answers to be between 0 and 2 pi. Okay, so no negative answers. So we got our first one going this direction, right? Pi over 3. And keep going all the way around till you get to this one. Okay, so that would be 5 pi over 3. Okay, and those would be the only two answers. Here, because it said just give the answers between 0 and 2 pi, you would just stop here. You wouldn't say pi over 3 plus any number of full circles, any 2 pi, 2n pi. You wouldn't do that in this case because they're not asking you for all solutions, only the ones that are between 0 and 2 pi, between 0 and 360. Anything outside of this will be outside of 360. Okay. All right, so that is it with our basic trig equations. So that wraps up chapter 7. So hopefully you're keeping up with the homework. Again, if you have any questions, make sure you message me or you email me. Okay, enjoy your day.